Electric field, we said, is a region where electrostatic forces occur between two charges. Now we say that electric field is the electrostatic force per unit charge. Now, per unit charge, you'll see that we use small q, but we know that we measure charge in Coulomb, and we know that we measure force in Newton. So we can actually say that the unit for electric field is Newton per Coulomb, or we can write it like this, Newton times Coulomb, but then it's above the line, which means the exponent becomes -1. Right. The SI unit is therefore Newton per Coulomb. The strength of the electrostatic force on a known charge at a point in an electric field can be calculated with this equation. So if we want to know the strength of the force, it's going to be equal to this charge multiplied by the electric field. So F equals QE. But we also know that the strength of electrostatic force can be calculated using Coulomb's law, which, as it is shown on your formula sheet, we write like this. F equals K Q1 Q2 over R squared. But now, we know with an electric field, we are working with a point charge. So instead of using Q2, I'm going to use small case q and rewrite this formula. So it's still Coulomb's law, but now it is K, Q, and now I don't have to say Q1 because it's already a capital letter, showing me it's a different charge, times small case q over R squared. But we also know that this F is equal to Q times E. That's the new formula we're looking at today. So I can also say that QE is now equal to K capital Q times small case q over R squared. And now you'll see we have a situation where we can cancel small case q on both sides. And that's why I said the point charge's magnitude or size doesn't really matter because we cancel it out on both sides. And now we have another formula that we can use for electric field. Remember, we started by saying E equals FQ, and now we can also say that E is going to equal K times Q over R squared. Now, as you know already, E is going to be directly proportional to Q. So as the charge increases, the strength of the electric field will increase. And we can also see from this equation that E is going to be inversely proportional to the squared distance between the point charge and the charge that we are looking at. Happy with that? Okay. So if you have a look at the bottom of page 229,